Good morning, boys and girls. On to 4.3 here. Today we're going to take everything we've learned about derivatives and we're going to be able to graph functions. All right? So let's go ahead and start here. Let me give us one to play around with. Okay, so back in Algebra 2 / trig pre-calc, to graph a function like this, we were kind of not stuck, but we had to have our calculator help us quite a bit along the way to graph a function that looked like this. But now we are going to be able to do, all of our graphing, any type of function, all by hand with our use of derivatives. We're still going to need to be able to tell all the important parts of this function. So let's start with our algebra pre-calc stuff. Question types like, how do we find the x-intercept? If you want to find the x-intercept of the function, if you remember, you're going to set the equation or the function equal to 0. So 3x minus x cubed equals 0. Going to go ahead and factor out an x, and I get 3 minus x squared equals 0. And then if I solve that, I'm going to get x equals 0. And a little solving here, you would get x equals plus or minus the square root of 3. All right? So those are my x-intercepts, or if I wrote them as points, 0, 0, root 3 comma 0, and negative root 3 comma 0. It's going to be very important on the test on this stuff that you label all the pieces. Okay? Tell me which piece goes where. Not where it goes where, but also tell me what it is. Hey, these are the x-intercepts. That's important that you're communicating that way. All right. Next piece of information we can find is the y-intercepts. To find the y-intercept, that is when x is 0, right? The x-intercept was when y was 0. The y-intercept is when x is 0. So now I'm going to plug in 0 for my x. And we get 0. So my y-intercept is at 0, 0. It's already 2 or 3, 4, depending on how you're looking at it, crucial pieces of information. But let's dig a little bit deeper now with this function. Let's see where it is increasing and decreasing, see if we can't find some mins and maxes. All right, so to find our mins and maxes, we're going to take this and we're going to find the derivative. So f prime of x, and we get 3 minus 3x squared, and we're going to set that equal to 0. And now we're going to solve. We get 3x squared equals 3, x squared equals 1, or x equals plus or minus 1. All right, so now I know that those are my critical points where some exciting stuff could be happening. If I do my little number line, hey, negative 1, 1, and I plug in on these intervals, I'd probably start with 0 because it's easy. If I plug in 0 to the derivative, I'm going to get 3. So that's positive. If I plug in here, if I plug in 5, I get 3 minus 3 times 25 or some big number. Again, I really don't care what the number is so much as the sign. So 3 minus some really big number is going to be negative. And then if I plug in a negative 5, the same thing, I'm going to get 3 minus some really big number or negative. So here this is telling me that we are decreasing, increasing, decreasing. And that means that negative 1, I should have a min. And at 1, I should have a max, since I'm changing from increasing to decreasing, and a min when I went from decreasing to increasing. All right. My min, let's start there, at x equals negative 1. If I wanted to find out what that was, if I wanted the whole point, if I wanted to find the minimum value, I'm going to plug it into the function. So if I do f of negative 1, plugging again back into the original function, not the derivative now, I'm going to get, let's see, negative 2. I'm just going to speed the math along there, but you can go and double check me if you want. I've got my notes. I'm cheating to the side. All right, so I know I have a min at negative 1, negative 2. And then for my max, same thing, at x equals 1, I'm going to go plug that in, hey, f of 1. And when I plug in 1, I get 3 minus 1, which is 2. All right, also again, I have a max at 1, 2. All right. In your work, again, I'm going to want to make sure that you label all of this stuff. Label your mins, your maxes, your x-intercepts, your y-intercepts. Not bad to do the intervals where you're increasing and decreasing. All right. Still, we can take this one step further than that before we start to try to graph this. I can now go and look at the second derivative and check out the concavity of our function. All right, so to look at the concavity, we're going to look at the second derivative. and we get negative 6x. Again, we want to set that equal to 0. We get x equals 0. We're going to do our little sign chart to see what's going on. And then if I plug back into the second derivative, if we plug a negative number in, a negative times a negative is a positive. And if I plug a positive number in, we get a negative. So we know that we do have a POI right here, right? We are concave up on that interval, and we are concave down on that interval. Okay? And there's a POI, a point of inflection, at, x equals 0. And again, I could go back and plug this back into the original function. I can plug it back into f. Hey, f of 0 is 3 times 0 minus 0 cubed, and we get 0. So 0, 0 is also a POI. Okay? All right, so now we've got all this information. We know about our x-intercepts, our y-intercepts, where it's increasing, decreasing, concave up, concave down. This is enough now for us to try to put together a sketch of this function. All right, I'm going to set it up here real fast. All right, so what did we find out again? Right, we started with our x-intercepts. We had an x-intercept at root 3, 0. Root 3 is like 1.7. So I'm just going to sketch it out like right there. And negative root 3, 0, right there. And then we also had an x-intercept at 0, 0. So right there. So we had those 3 dots. We found our y-intercept was also at 0, 0. We already have that point marked. We found we had a min at negative 1, negative 2. And we had a max at 1, 2. So we can put those points on our graph. And then now putting together what we knew about increasing, decreasing, concave up, concave down. We knew we were decreasing from negative infinity to negative 1. And we are concave up, right? Concave up on that interval. All the way to, negative 1. At negative 1, we are still concave up, but we started to increase now. So still concave up, increasing. All right. Then at 0, 0, that was our point of inflection. So we switched from concave up to concave down, but we are still increasing. So now I'm concave down and increasing. And I find like when I'm trying to graph concavity, it's easier to start from these max and mins and not from like the POI. And then now at 1, 2, I know that I'm starting to decrease again because it was a max. And now I'm decreasing and concave down the rest of the way. Decreasing, concave down. And so our function, we can actually get a pretty decent looking graph, of our function with the changes in concavity and increasing, decreasing, all with our knowledge from the derivative. So that's pretty cool. Let's try this again. Okay, for this one again, we're going to graph it using all of our knowledge. I would say start off simple with, again, your x and y intercepts. I'm going to go find those now, and you can just look at my work when it pops up. All right, so again, to find your x-intercepts, you're going to set the function equal to 0. So 3x over x squared minus 1 equals 0. In order for that fraction to equal 0, just the top is going to equal 0. So 3x equals 0, so I get x equals 0. And so I know I have an x-intercept at 0, 0. Now let's find the y-intercept. Again, to find the y-intercept, you're going to plug in 0 to the function. You're going to make your x 0. And so if I do that, I get 0 over negative 1, which is 0. Or again, my y-intercept is going to be at 0, 0. But I found those 2 pieces of information. Again, make sure that you notate them so I know that you know what each one is. All right. Now let's go look at the increasing, decreasing of the function with the first derivative and our mins and maxes. Okay. If we want to know about the mins and maxes of a function or the increasing, decreasing, we're going to look at the first derivative. In order to find this first derivative, I'm going to have to use the quotient rule. And again, I'm going to kind of put the work up on the board here, and you can look it over. We'll talk about it in 1 sec. Okay, so to find this first derivative, we had to do the quotient rule. Low, d high, minus high, d low, square the bob, and off we go. With a little simplifying action here, multiply it out on top, combining like terms, we get the first derivative. Again, to find my critical values, I need to know where the derivative, the first derivative, equals 0 or is undefined. So let's go find those. All right, so for finding where the first derivative equals 0, you're going to set the top equal to 0. When I solve this, I get x squared equals negative 1, which is not possible, or you're going to get imaginary solutions, which means there's no critical values where the derivative is going to equal 0. Now, it's also where the derivative is undefined. So for that, I need to set the bottom equal to 0. And so this is going to equal 0 when x squared minus 1 equals 0. I solve that and I get x equals plus or minus 1. So now the only real critical values I have are at plus or minus 1. So let's do our line test. To do your line test, you're going to want to plug back into the derivative, right? And so I'd plug in right here, and hopefully we can all agree that the bottom will always be positive. So I really just need to look at the top of this thing. If I plug in again, I would probably start with 0. If I plug in 0, I get negative 3, so that's going to be negative. If I plug in a really big number like 10, I'm going to get negative 300 minus 3, which is negative. And if I plug in a really small number like negative 10, same thing, I'm going to get negative 300 minus 3. So we get negative, negative, negative. All right, now you might be asking yourself, okay, so this is decreasing the whole time, right? Decreasing, decreasing, decreasing. So we have no mins and maxes. And you might also have, like, so what's going on at negative 1 and 1 then? Why isn't it decreasing or increasing at those values? Let's go back to our original function and again, think about what's happening for this thing. If we graph these things before, that's a rational function. And when the bottom equals 0, which is what we're doing down here, right? You got vertical asymptotes. So we actually have a vertical asymptote at plus or minus 1. Now, other things we're going to want to keep in mind when we graph this thing is when we did this, we also found horizontal asymptotes, right? And so because the degree at the top is less than the degree at the bottom, or if we looked at the limit as x approaches infinity, the end behavior of these things, we're going to get, that's going to be at y equals 0. Ways of kind of evaluating the things, either, using our rules from algebra or, our limit rules from earlier in this unit. All right. Now we know about the increasing, decreasing part. There's no mins and maxes. It's always decreasing. We know there's some asymptotes. Now let's go look at concavity. All right, so for concavity, we're going to look at the second derivative. So now I got to take the derivative of the first derivative. This gets a little bit gnarlier here in this case. So low d high minus high. For the d low, don't forget, you're going to have to use a little chain rule here, right? So 2 times x squared minus 1 times 2x. Square the bottom and off we go. All right, now I'm going to tidy this up. Okay, this looks a little bit nicer now. I just moved the negative 6x in front. I took a negative 3 out of this here and multiplied the 2 and the 2, so I got positive 12x now times x squared plus 1 times x squared minus 1 all over x squared minus 1 to the 4th. All right, and now before I start setting this equal to 0, I'm going to have to do some factoring to make our solving a little bit nicer. Okay, so I factored out a negative 6 and an x negative 6, an x, and an x squared minus 1. So that leaves me with an x squared minus 1 in the front term here. And then it leaves me with negative 2 from here and an x squared plus 1 in the back. Now I'm going to put all this stuff together. Okay, so sliding up here so you can see my work. We combined everything from right here, and I got negative 6x times x squared minus 1 times negative x squared minus 3. And then I factored the negative out of there. And so I got a nice simplified form of 6x times x squared minus 1 times x squared plus 3 all over x squared minus 1 to the 4th. All right. Now I want to set this equal to 0 and find my critical values. And if you do that, you're going to get x equals 0 and x equals plus or minus 1. That's my critical values. And now we need to test those. All right, as we go to test these, just a few things real fast. You're probably wondering why I didn't kill off this x squared minus 1 right here, and you totally could. But I left it there for a reason because when I raise this to the 4th power, that's always going to be positive. So I really don't have to worry about it. And this x squared plus 3 is always going to have to be positive. So as I test values now, I'm really just going to test them in these two things right here. And that's all I really have to worry about. As I plug my stuff in, I want you to go and think about it. But when you plug in, it should be a little something like, when I plug in a big negative number, this is going to be negative because I get negative times a positive. If I plug in a small negative number, I'm going to get a negative times a negative, which is a positive. A small positive number is going to be negative, and a big positive number is going to be positive. So we end up here with a POI at 0, 0. And then again, we have the weird asymptotes at negative 1 and 1. Otherwise, we got concave down and concave up. Now let's give this a quick sketch. The first thing I would do is draw my asymptotes on the function. We had them at 1, negative 1, and 0. In this case, we only had one critical value, 0, 0, right? That was our POI and our x and y intercepts. All right, and we know our function is decreasing on the entire interval. So decreasing and concave down, and so because it's decreasing, it has to be in the spot right here. I know that I am decreasing and concave up from 1 to 0, and then decreasing and concave down from 0 to 1. And then I'm decreasing and concave up, so that would have to be right there. Thanks, boys and girls. See ya.